Hello, welcome to my channel. Today we will start chapter 9. Okay, so let me do this first question. Sketch the curve y equals 3 cos 2x minus 1 for this range. So I hope it's easy. You can see that how do we sketch the cos x? Cos x goes like this, right? So this is plus 1, minus 1, and this is 90. This is 180, 270, and this is complete cycle 360 degree. Okay, now we want to plot only up till 180 degrees, so basically we want up till here. Okay, now what about cos 2x? Okay, I hope you understand that cos 2x means shrinking this in the x-axis, x direction. So up till 180 degree, we have only half cycle, and now we will have full cycle in this range. Okay, so this is 180, this is 90, plus 1, minus 1. Okay, now the next step is 3 times cos 2x. So it's the same graph, scaled in the y direction. So this is still 180 and 90, but this time it is 3 and minus 3. Okay, and finally 3 cos 2x minus 1. So it will go down by 1. So it will be the same graph, but it starts from 2 and goes up till minus 4. And this point is 180 and this is 90. Okay, let me share a better uh, graphs. So just stay with me. Um, I want to share this graph. Okay, so you see, this is the graph of cos x. Okay, I cannot plot right over here, sorry. Okay, so this is the graph of cos x, and then this one is cos 2x. You can see the frequency has doubled. So in 180, before it was half cycle, and now you have full cycle, as I showed you before by hand, by making by hand. Okay, now this is 3 times. So let me change the scale in the y-axis. Y direction is 3. Let me make it 5 and minus 5. Okay, so you can see by making it 3 times uh, cosine of 2x, it is increased the y direction. And finally, when you subtract 1, it will go 1 unit below. So it goes from 2 to minus 4. So let me remove all the previous ones. So this is my final graph. Okay, I hope it is clear. Let me go back to the other screen. Okay. Mm, yeah. Okay, so this was question number 1A. Okay, now I'm going to do 1B. So let me remove all this thing. The fill button, yes. Okay, now question number 1 and B. Okay, it has again 2 parts. One is still the amplitude. We need to find the amplitude of 1 minus 4 sine 2x. Okay, so let's see. How about sine x? It goes like this. right? Okay, how about sine 2x? So the frequency is doubled, so it will go fast, right? Okay. I don't care, I'm not very particular about the plot along x-axis because I'm concerned about the y-axis, about the amplitude. Okay, so this was plus 1 and this was minus 1, and similarly, this time my graph is between plus 1 and minus 1. Okay, now if I multiply this thing by minus 4 sine of 2x. So you can imagine that it will change the sign and increase the amplitude. So this time it will go from plus 4 to minus 4, right? And finally, when I add 1 into it, it will become 1 minus 4 sine 2x. So by adding 1, the same graph will shift upward. So it will start from here and go something like this. So this time it is 5 and this point is minus 3. So my graph of this expression is between minus 3 and 5. Okay, so how do we define the amplitude? Okay, let me sketch it again here. I have something going from minus 3 to 5. So this is 5 and this is minus 3. So how do we define the amplitude? This is interesting. Okay, amplitude is the swing around the mean value. You can see that the mean value or middle point of 5 and minus 3 is 1. Do you agree or not? Right? From 1, it is 4 unit up, and from 1, it is 4 unit down is minus 3. Right? Now, from the mean value, how much it is swinging on each direction? It is going this way by a 4, and it's going this way also minus 4. So the amplitude is this maximum swing around the mean value. So the amplitude is 4. Okay, I hope it's clear. So this is the part 1b and the first part of it. Okay, now I want to do the second part. So I need again some more space. Let me erase all this thing. Okay. This too. Okay, so now I'm doing question number 1b part 2. Okay, state the period of, now I want to find the period of 5 tangent 3x plus 1. Okay, this time I'm interested in about the x direction, the on the plot is in the x direction. Okay, remember tangent x goes from 90 to minus 90. So this is 90 and this point is minus 90. Right? Okay, so this is 180 and this is 270. Now the next cycle, and this is the line, the asymptote. I hope you know what is asymptote. Okay, so next graph is like this. Okay, so this is the graph of tangent x. Okay, so what's the period here? You can see that in this case, the period is 180. Okay, because from here to here it is 180, and from here to here is again 180. So it is repeating after every 180. Okay, now if I do tangent 3x, what will happen now? It will shrink in the x-axis by 3 times. So instead of 90, it will go from 30, something like this. Something. So, and this is minus 30. So graph will go from 30 to minus 30. Okay. Okay. Yes. In the same way, next time it will go from here to here. Okay. So you can see that this time the period of this one is 3 times less. So it is 60 degree, right? Okay. Now, when I multiply this tangent 3x with 5, 5 tangent 3x, it will amplify in the y direction by 5, but it will not affect the period. Similarly, if I add 1 into it, the whole graph will shift up by unit 1, but again it will not affect the period. So the answer is period is 60 degree. Okay, I hope it's clear. Okay, let me move to the question number 2. Okay, let me erase this thing again. I need some space. Where is, yeah. Okay, now, uh, yes, erase this. Okay, now I want to do question number 2. Okay, solve. Okay, this is a bit challenging question. 2 times cos 3x equals cotangent 3x. Okay, and we need to solve this equation and find the values of x. And our x has to be between 0 and 90 degree. Okay, you can see 2 cosine 3x equals cotangent is cosine over sine. Okay, can I cancel cosine 3x with cosine 3x? Yes, but not exactly. You see, canceling means I divide both sides by cosine 3x, right? But I cannot divide by 0, remember? So this division is valid as long as this cos 3x is not 0. So we will consider the case when this is equal to 0 later. But I assume that right now I'm talking about when cos 3x is not 0, so I can divide both of them. So it will become 2 times 2 is equal to 1 over sine 3x. Okay, so from here you can see that sine 3x is equal to 1 by 2 and 3x is equal to sine inverse 1 by 2, and sine inverse 1 by 2 is what? I'm talking about in the range of 0 to 90 degree. Okay, remember the graph of sine x goes like this. So this is 360, this is 180, and this is 90. Okay, and since I'm talking about 3x, so it will shrink by 3 times. So I will have similar thing, but now this will be 30 degree and this point would be 60 and this point would be 90. My tying is not very good, so I hope you can mix. Okay, let me do this part again. Yeah, okay. So I'm saying that I'm going to sketch is for this one period only. Okay, so now this is, as I said, it is 30, this is 60, and this is 90. Okay, and for what value of 3x, my answer is half. So half, remember, this angle would be how much? It is going to be 10 degree. Does it make sense? Okay, let's talk about sine inverse half. Sine inverse half is when angle is 30 degree and 150 degree, right? So this is 30 degree and 150 degree. Okay, so x would be equal to 10 degree and 50 degree. You can see here it is 10 and here it is 50. So if I make a graph of sine 3x, then I can find it like this. And if it's the graph of sine x, then it's like this. It is 30 and 150. Okay, so I got these two answers when I divide this whole equation by cos 3x first. Okay, now let's consider the case when I do not divide. Okay, because remember I told you that this division is valid only when cos 3x is not 0. So if it is not 0, it is valid up till here. What if cos 3x is 0? Okay, if cos 3x is 0, it means that 3x is equal to cos inverse 0, right? Okay, now cos function, let me sketch it here quickly. Cos function goes like this, right? So this is 90, this is 180, and this is 270. So you can see that cos x is 0, and cos inverse is 0 when angle is 90 degree or 270 degree. So from here, x should be 30 degree or 90 degree. So my answers are x equal to 10 degree and 30 degree and 50 degree and 90 degree. So for all these values of x, this equation is valid. Okay, so this was question number 2a. Now I will solve question number 2b. Let me erase everything here again. So now I want to do question number 2b. Okay, this seems a bit easier. We need to find secant of y plus pi by 2 equals -2. Okay, so secant is 1 over cosine. Am I right? Cosine of y plus pi by 2, and this is equal to -2. Okay, so it means if I take the reciprocal on both sides, it will become cosine of y plus pi by 2 equals -1 by 2, right? And if I expand this left side, it will become cos alpha cos beta minus sine alpha into sine beta equals -half, and 90 degree cosine pi by 2 cosine is 0, so it all becomes 0, and 90 degree sine is 1, so it becomes 1, so I will have minus sine y equals -half, so sine y equals half. Okay, now for what values of so y is equal to sine inverse half. So the question is for what values of y the sine is half. So you remember sine curves goes like this. This is 360. This is 180. So half. So one value is 30 degree and the other value is 150 degree. Okay. So this, yes. So the answer is 30 degree and 150 degree, and in radians it is going to be pi by 6 and 5 pi by 6. Okay, so this is question number 2. Now for question number 3, I can do it now. The video will become a bit longer, but okay, let me do it in the next one. Thank you very much for watching. We will do question number 3 in the next one.